So hello guys, today we are going to do a liquid question that goes by the name word search. The question number is 79 and it's a medium level question. Okay, so what we'll first try to do is we'll first try to read the problem statement and then we'll go on to the solution. Okay, this is what we generally do. Okay, so let us first try to read the problem statement, what the problem statement says, and then we'll see whether we can arrive to the solution or not. Okay, so let us start. Given an m into n grid of characters, board, and a string word, return true if word exists in the array, in the grid. Okay, so you are given a grid of characters. As you can see, you are given a grid of characters and a string word and a string word. Okay, what I have to do is if this word is present in my string, if this word is present in my grid, then I'll simply return true, and if it is not present, then I'll simply return false. What does I mean by that? Word can be constructed from letters of sequentially adjacent cells where adjacent cells are horizontally or vertically neighboring. The same letter may not be used more than once. The same letter cell may not be used more than once. Okay, so as you can see, you are given this grid, and what you have to search, you have to search for the word A, B, C, C, E, D. So if you can see, you can just see this word A, then B, C, C, E, and D. Okay, so this word is being formed. This word is being formed. And in the second example also, like you can see, a grid is given, and you have to search for the word C. So C, 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 C. So how can I search for the word C? Basically it is starting at letter S. So what I'll search is I'll search for the letter S and then C. So S. Is it like making any C? No. Okay, this S. Okay, is it making any C? Okay, this side. No, it is not making any C. This side. Okay, it is making a C word. Okay, now in this grid I have to search for the word ABCB. ABCB, I have to look for the first character because ABCB starts with A. I'll simply look for the first character. Okay, so I look for A. I look for whether it is forming the string A, B, C, E. Oh no. Okay, so I'll just move forward and look for another A. My A is here. Is it forming A, B, C, B? No. Okay, so as you can see, this is what we have to do. This is what we have to do. Okay, and beside explaining the question, I just told you the approach also. Okay, you just get to know. Just get to know. Okay, so suppose if I just see this example, A, B, C. Suppose we are given a grid. Okay. Okay. One, two. I think this. So it is given like A, B, C, E, S, F, C, S, and then A, D, E, E. These are the words. This is the grid that you are given. Okay, this is the grid that you are given. And what you have to search? You have to search for the word C. C. Okay. So how can I do this? How can I do this? How can I do this? Let me make some simple observations. Simply simple observations. Okay, simple observations. So if I have to search for the word C, how can I search for this word C? Basically, for searching any word, will I see the exact occurrence of the C, that C should occur here or here or here? No, no, no. I'll just put up I on my first element and then I'll search for this S only. I'll search for this S because it is easy, right? I'll search for this S only and then I can see. So I'll just start iterating from here, here. Okay. I get one S. I get one S. Okay, I get one S. So I'll just check whether it is forming my answer, whether it can give me a particular string. So okay, I'll get to S. Am I getting the next character? Am I getting the next character? S E E. E is E anywhere beside this? No, no. So this cannot be my answer. Okay, I'll just continue my iteration. I'll go to the next S that is coming. Okay, next S that is coming. So my S is coming here. S is coming here. Okay, so now when I got my S, now I look for E. Now I look for E. So E is present at this place as well as this place. I'll look for this E. Okay, I'll look for this E. Okay, I'll look for this E. My pointer moves forward. My pointer moves forward. My pointer moves at this place. I will look for the second E. So can I take this E again? No, because it is strictly given that we cannot use duplicates. We cannot use duplicate, like this element duplicate we cannot use. Okay. So basically this cell we cannot take it again. So for marking this block, I'll simply mark it with hash. I'll just remove this character and mark it with hash, and for remove this character and mark it with hash. That simply means that I have used this. Okay. And when I look for this e, I've just getted that no e is present. So what I'll do is, should I move forward? No, I'll simply backtrack. I'll simply backtrack. Okay. I'll simply just forget all of this that I've ever moved here. I just make it S and S make it E and again start here because my E was also present here, so I'll start here. Okay, my pointer moves at the first place. It is again at this S. Okay, I got my S. My pointer moves forward. It moves at this place. So I am looking for E. Have I got my E? Yes. Okay, I'll just move forward. This E. Okay, have I got my E? Is my E present anywhere beside this E? Because basically, I'll just remove this and mark it with hash. This also I'll remove it and mark it with hash. Okay, so I cannot just search it here. The only place to search is for here. Okay, so I got my E and my iteration is over. So I'll just simply mark it with hash. And when a pointer is right here, that my pointer has traversed the whole string, this is the point I return true, that I have found my string. As you can see, we are basically following a simple backtracking algorithm. Okay, backtracking algorithm. Because suppose I am looking for my S in this case. In this case, as we were looking for my S, basically my S was present here, E was present here, and E was present here. Okay, so I was looking for my S. My S had this option and my S had this option, and now also I had this option as well as this option. So for exploring all the possibilities, the only thing I can think of is like backtracking. Basically, I can get to this solution, I can get to this element, and if this element is not able to satisfy my condition, I'll simply backtrack. Okay, so this is what I am following. Okay, so what should be my general approach? I'll just take another example, another test case. We're getting bored with the test case. Okay, I'll just take another one to make it interesting. So A B C E S F C S A D E E Okay, and what I have to search? I have to search for the word ABCCED. Word is ABCCED. Okay, what I'll do is I'll simply mark my element here, mark my pointer here, because I have to search for this character only. I don't have to search for this B, C, because this doesn't make any sense. I have to search for the first character because see, if you have to search for some element, you will just look at the first character, right? You won't look at all of these elements. I don't have to look at all of these elements. I'll eventually look for them, but I don't have to look at the first. Okay, so I'll look for the A. Okay, I'll look for the A. So have I got my A here? Yes. Okay. What are the places that this particular position can explore? Basically, you are given with that. You can just go horizontally or vertically. Okay. So what are the options that this position possess? Does it possess this option? No. Does it possess this option? Yes. So this is one choice available, and this is another choice available. So this position has two choices available. Okay. So what I'll simply choose one of them. And how I'll choose? Basically, I'll simply get to this element. Okay. I'll check whether it equals my second pointer, whether it equals my this value. It equals. Yes, it does. But what if I move to this position? It was not able to satisfy my conditions. Okay, it won't be able to satisfy my conditions. Okay, I came at this place. I just saw that it is following my conditions. Okay, and whenever I moved, I just mark it with hash. And this also I'll mark it with hash because this simply means that I have just iterated through it. And I don't have to iterate it again. Okay, now, when I've come to this position, what are the elements that I can explore? Basically, if these are my column number and this is my row number, what are my possibilities? I can basically just check for this. and I can check for this, and I can check for this, but this already contains my visited element. So I am left with only two options, either this or this. Okay, so if I just move towards this side, if I just move towards this side, I'll get to see my pointer comes here. I'll get to see my pointer comes here. Okay, 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 seems like a valid one. Okay, so I'll mark it with hash. I'll mark it with hash. I'll move forward. I'll move forward, and my this pointer also moves forward. It moves to C. It moves to C. Okay, it also has two options. It also has two options. Okay, it also has two options. Whether to go here, whether to go here, or here, whether to go here or here. It cannot move backwards because this is already been marked. This is already been marked. So if I just try to iterate to here, I just try to iterate to here or here. Okay, if I just try to iterate to here, see, it is not matching. This element is not matching with my current element. The pointer is on. Okay, so I'll simply backtrack. I'll simply backtrack. Okay, so whenever I go to element, I'll simply mark with hash. But if this is not the solution, I'll simply backtrack and mark it again. Okay, then I'll go on to check the solution. Then I go on to check the solution. Okay, I'll go on to this element. I'll go to the C element. Okay, I'll go to the C element and I'll check whether these elements are equal. Yes, they are equal. Okay, so I'll just move forward. I'll just move forward. Before moving forward, I'll just mark it with hash. Okay, I move forward. I come to this element. I come to this element and my pointer moves forward. And when I come, I'll simply mark with hash because I have visited this element. I have visited this element. Okay, so I'll simply mark it with hash. Okay, okay, okay. So now it has how many options? It can just traverse in this direction, or it can traverse in this direction, or it can traverse in this direction. But this is already being traversed. This is already being traversed, so I don't want to just go till here again. So I'll just come to this element or this element. Okay, so I'm already on my pointer E. Okay, so whenever I just move forward, my pointer will move forward. Now it is pointing at D. So if I come here and mark it with hash, is it matching with my current element? The pointer is on? No, no. So I'll just mark it again. I'll just mark it again. Okay, so this route is just deleted. So if I just try to come here, if I just try to come here, is G matching with my current element the pointer is on? Yes. Okay, I'll just delete this and mark it with hash. Okay, so what I get is my answer string is basically this. And this was basically A, B, C, C, D, E and D. E and D. Okay, this is my overall solution. Basically, what I'm doing is as suppose this is the string I want to look for. So I am looking for the first element. I'm looking for the first element. And if my first element is matched, if my first element is matched with any other element, like if my first character is matched with the character in the with the character in the grid, with the character in the grid, okay, match with the character in the grid, then only I'll do recursion. Then I'll do backtracking or recursion. Okay, then only I'll do backtrack. Okay, then only I'll do backtrack because that is the only case when I have to move forward. Else I don't have to move forward. Okay, else I don't have to move forward because see, because if this is what I'm looking for and the grid has a character B at the start, B at this place, like basically if the 1 2 position contains B, so there is no use of giving it to the function, right? Because this is not gonna get me my answer anytime anytime because my string is starting with A, and if I just pass it, it will simply get rejected. It will simply get rejected. So what I have to choose, basically, if my grid is something like this, so I have to choose all the strings. I have to choose all the positions that are starting with A. What I'll do is I'll simply just iterate through n squared loop because this is a 2 into 2 matrix. Like basically not 2 into 2, n into n matrix. Okay, so just I'll mark my O of n squared algorithm, and whenever my grid of row and column matches, whenever a grid of row and column matches, then I will simply then I'll simply move it to my function. Move it to my function. Move it to my function. Okay. 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 Now I know. Now I know one thing, that if my first character matches, then I'll move the whole string. Then I'll move then I'll move it to the function. Okay, but what is my function? What is my backtracking function? What it will do? Okay, I'll just take an example again, this example again, and just tell you. Okay, ABCE, SFCS, and then ADEE. ADEE. Okay, so this is what I am getting, and what I have to look for, I have to look for C. This is the word that I have to look for. Okay, okay. So you just tell me one thing, that for any position, for any position, what are the possible moves that a position can make? Either it can go upward, either it can go right, either it can go left, or it can go downward. Okay, so if I just mark the row number and the column number, so if I move, like suppose suppose I am at this element. Okay, I'm at this element. So this position is basically 1:1. This is 1:1 that I'm standing at currently. So if I just move upward, what is the indexes of B? What are the indexes of B? 0 and 1. 0 and 1. So I can see that whenever I move upward, my ith value decreases. So up can be like, if these are represented as my row and call variable, these are represented as my row and call variable, so it can be row minus 1 and column, because my column value remains same. See, if you are moving upward, your row was this and now it is this. So when you are moving upward, your row value will decrease and the column value would remain same. Okay, this can be my first case. Where I can move after finding a successful element. Okay, after finding a successful element. Okay, what is my second case? Okay, simply just see, if I don't move upwards, what is the second position I can move? I can move downwards. And the reverse would happen, because if I move downward, this 0 would become 2, because see, I was at this row and it came at this row. So my row would increase, and the column would remain same. So this is my second case. What about my third case? So I simply see, I have covered about the upward and the downward, so I am left with right and left. So when I come to right, I can simply see that the column value is increasing and the row value remains same, because I am at the same row, but the column value is getting changed. So my row would remain same and my column value would increase. So it would be column plus 1. This was for upward, this was for downward, this is for right, okay. And if I just try to go left, that is my fourth case. Okay, so my column value would decrease, but the row value would remain same, so it will be col minus 1. Okay, so I have covered about all the four cases. But yeah, but whenever I am standing at this position, only three moves are possible, right? There is no top move possible. So we'll just make a case that if the position that we are searching for is less than 0, or at this position, if it is greater than, because basically if it is anywhere, like if it is anywhere like exceeding the limits of the box, I'll simply return false. In this case. So only the limited movements would be allowed. Only then limited movements would be allowed. And what would be my valid case? Till all the elements are being matched. Because if I just come to this character and if I just pass it, okay, till 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 I am left with only one element that I can explore, and that element is not equal to my particular character, then only I'll return false. Else I would return true. In that case, basically in that case, when when my pointer reaches to the end, reaches to the end of the string, reaches to the end of the string. Because at every iteration, when I'm just iterating this pointer at the front, and I'm iterating this pointer at the front, so whenever it reaches at the last position, whenever it reaches at the last position, it simply means that whole string has passed. Whole string has passed. Okay, whole string has passed. Just remember one thing. Just remember one thing. Just remember one thing. F C S E E and E. Okay, just remember one thing. Whenever you are just traversing, just mark the current element that you are traversing with hash. Okay, and if this is not the possible solution, you have to mark it again with E. You have to mark it again with E. Why? Because if you don't mark it with E, it will still remain hash and it cannot be used for any other traversals. It cannot be used for any other traversal. Suppose basically you are given with something like this. Okay, SEA, and you would be given like something SEE, okay, or any other case. Basically, if you just mark it with hash and you just don't replace it back, so it can be a part of some other answer. It can be a part of some other answer because, but if you don't replace it, you won't get the answer anytime. You won't get the answer anytime. This is what we are doing. This is what we are doing. Now I'll tell you a case where it doesn't pass. In this case, basically, ABCE, SFCS, ADE, and basically I have to look for ABCD. Let us suppose we have to look for ABCD. Okay, I'll just look for the first element. I'll look for the first element A. Okay, A passing. Okay, what are the possible moves? This and this. If I just go through here, it would be simply returned by false. If I go to here, it will be simply returned by false. Okay, okay. It will try to traverse, but false would be returned. So there is no use. Okay, I'll move to this element. Okay, I'll move to this element and I'll mark it with hash. I'll mark it with hash. Okay, I'll move forward. I'll mark it with hash. Okay, I have this two options. I'll just move forward. This element is matching. I'll mark it with hash. I have just two options, this and this, this and this. So I have to move forward. I have to move forward. I will move forward in this direction and I will move forward with this direction. But I don't get any answer. So I'll simply just backtrack. I'll simply just backtrack. And what I'll say is I get my answer. I'll just get the elements back. I'll just get the elements back. Okay. Okay. So I'll move for. Okay. So after coming to this element, I'll just simply move my iterator back. My iterator would be back at A again. Okay. I'll just select. I'll just look for another A. I'll just look for another A. Okay. So I'll look for another A. I'll just mark it with hash. Mark it with hash. But I have to store it at some place so that it can be just reversed again. It can be reversed again. Okay. Okay. When it moves forward, it can move in this direction or it can move in this direction. It cannot move in this direction or it cannot move in this direction. Okay, so two options are only possible. So if it moves in this direction, no, the element is not matching with the current string, current character. Okay, if I move in this direction, no, the current element is not matching with the current element. Okay, okay. So none of the answer is found. Okay, because if the first character is not itself matching, there is no point. Now I'll simply try to code the approach. You will get a better idea. Okay, I'll just mark it with 0. Okay, I'll just mark the size. I'll just mark the size, and I'll mark the size of. Basically, this denotes the size. This denotes the number of rows, and this denotes the number of columns. Okay, and my row and column are initially zero, or I'll just move forward with this. Basically, I have to check through the whole loop. Okay, and I'll use the typical n square approach. I'll use the typical n square approach to just iterate through all the elements. And whenever I find that my current element is matching with the first character, with the first element of my word that is to be sourced, I'll simply call my helper function. Okay, and if both of these are possible, I'll simply return true. Else, if this iteration ends and I don't find any solution, I'll simply return false. I'll simply return false. So this is the overall layout of my main function that I want to return. I'll just define this helper function now. But if this helper function is returning me a true, that means that the string is found, and I don't have to look again. Okay, and I don't have to look forward. I'll simply return true. Okay, so I'll make a helper function. What I need, first I need this vector of character board because I need this board desperately. Okay, without this I cannot do anything. I need this n, I need this m, I need my I need my j, and what I need is I need my index. What is this index? This index will basically denote what character my string is particularly at. Basically this pointer is represented by my index. Okay, okay, so if my index equal to my word dot length, if it has reached at the last, I'll simply return true. Basically, if my this pointer has reached to this position, it has successfully traversed all the 4 elements and has reached to the last position, I'll simply return true. Okay, I'll simply return true. Okay, what can be my answer? What are my possible answers? Okay, I'll just pass this board and board. Okay, n and m are passed as same. Okay, I just saw that I have 4 options of passing. All the elements have 4 options. Okay, in which the particular character can traverse. So first is row minus 1 plus column. That is the case when we go up, because 1 up would be row minus 1 basically. Row minus 1 and column. So row minus 1 and column. Okay, so I minus 1 and j. So it would be like I minus 1 j, and it would be given by index plus 1, because if this is a successful iteration or it is not a successful iteration, I'll just simply move it. But before it, I just have to do one more thing, that I have to mark this element, so that I'll just see that this element is being traversed. So I'll mark it with hash. This hash means that this element is being traversed. Okay, now this covers my case when I go up. Okay, this covers my case when I go up. Now when I go down, okay, so this would be represented by my second option. Okay, this would be like board word nm. Then what was my second option? I can go down. So down would be represented by row plus 1, because see this, I was at row this, and when I came to this, my row number increased and my column number would remain same. So I plus 1 and then j, and then index plus 1 is compulsory because it would be done. Okay, now when I go right, just try to analyze. When I go right, my row would remain same, because see, I'm moving in the same row, but my column number would increase. So my third option is to go to the right. Okay, to go to the right, my row would remain same, my column would increase, and my pointer would definitely increase. And when I go left, basically it's the same row. When I go left, my column would decrease. Okay, my column would decrease. Just see, we are just taking all the possible combinations of this, and before ending, I have marked this element as visited. So I have to mark it again. I have to mark the element again. So board of I of j is equal to temp, to mark it again, and what I have to return? Answer of 1, answer of 2, then answer of 3, then answer of 4. Okay, so this is what I have to return. Why this? Because basically, if any of the paths, like basically traversing the upward, right, left or down, any of this would give me a true. If any of this would give me a true as answer, I simply all the elements, all the, like, the cumulative answer would become true. Because or, as you know, in our table, in our table if any one of these is true, then the overall answer becomes true. Okay, in this case only it is 0 when both of them are 0. Okay, Am I missing anything? Am I missing anything? Yes, yes. I choose the four cases. I chose the four cases. But I just told you this is valid for the middle elements, though that have the possibilities of traversing all the four sides. But what about these elements that cannot travel in one or more directions? That cannot travel in one or more directions. So I'll just add a case at the front that if my I is less than equal to less than zero, or my j is less than zero, or my j is greater than equal to m, or my I is greater than equal to n, or my word of index is not equal to my word of I of j, I'll simply return false. I'll simply return false and just I'll complete my function. What I'm passing board, I'm passing word, I'm passing n, I'm passing m, I, then j, then index. Index is basically zero. Okay, this is my overall function. This is basically, it will not cross any bounds, and if it crosses any bounds I simply return false. Or if my word that my pointer is on and the current element is not matching, I'll simply return false. I'll try to run it. Okay, try to run it again. I'll try to submit. Submitted successfully. Okay, so if I just try to just move through the code again, okay, what I'm checking is I'm checking nothing. I'm checking if the is first element first character of the word to be searched is equal to my current element. So I'll just simply iterate it through the O of n square approach. I'll simply iterate it through the O of n square approach. Okay, and if both of these conditions are fulfilling, that is, my helper also returned, my recursive function also returned an answer that there exists an answer. Yes, there exists an answer. So true would be returned, else this false would be returned. I'll just move through the helper function again. Okay, if my index has reached, basically if my string to be searched is traversed fully, then simply return true. Then simply return true. Okay, and just I'll mark the element. I'll mark the element that is traversed. I'll just mark the element that is traversed. Okay, and that then I'm just exploring all the four possibilities, and I'm marking my element again, marking my element with the character again if the solution is not possible in that case. Okay, so it is basically redoing its mistake. Okay, if I'm just marked this e with hash, okay, so I'll just mark it again. I'll just mark it again with the particular element. So at last, if I get any answer from any of these operations, basically from answer 1, answer 2, answer 3, or answer 4 would give any of them would give me a true, then my overall answer would be true. My overall answer would be true. Okay, this was the overall solution of the question, word search. I hope you guys like the solution. If you have any doubts, you can just ping it out in the comments. And if you like the solution, do like, share, subscribe. Thank you. Have a nice day.